Hello, welcome to the summary of the first lesson in the triangle congruence unit. We did this lesson on January 4th and 5th in my class just after the new year. So before break, we learned that you can transform these objects, to make them land on, congruent objects somewhere else. So this triangle here on the left, let's call it triangle 1, and this triangle here on the right, triangle 2, these triangles are congruent to one another. And I could prove that to you if I were to somehow, make this one land on top of this one. And I don't have the technology set up to do that right now. But imagine if I reflected triangle 1 over that red dotted line I just drew, it would land on triangle 2. And that would show you that these two triangles are congruent. But what we're starting to work on now is a way to logically show, without doing, transformation, that triangle 1 and triangle 2 are the same size and shape. Now you notice that I labeled there are three sides to these triangles, right? S, S, and S. There are three angles to these triangles, A, and A. And of course, the corresponding sides are congruent and the corresponding angles are congruent in the two triangles. And it turns out that, if the two triangles are congruent, then all six parts, all three angles and all three sides are going to be congruent. However, if I want to prove that the two triangles are congruent, do I need to know that all six parts are congruent before I know that? The answer is no. You only actually usually you need three parts to be congruent. And that's some combination of sides and angles. Okay, so and we're going to look at some of those combinations today. But just to give you an example, first of all, if you think about like the different ways that we could combine them, we're going to look at SSS. That stands for side, side, side. We're going to look at side, angle, side, and we're going to look at angle, side, angle. So all three of these, it turns out, I'll just tell you, are ways that you can show that triangles are congruent. And we'll look at that in a moment. But let's look at one that doesn't work. What if you used angle, angle, angle? Okay, what if you just showed, okay, I have one triangle and the, let's just draw a triangle here, and I'm going to do my best to make it look like it's equilateral. Okay, so that's an equilateral triangle, and so therefore I know that the three angles in this triangle are 60 degrees. Okay, because that's how equilateral triangles are. The three angles are congruent, and 180 divided by 3 is 60. Now I'm going to draw another equilateral triangle, and I know that that in this equilateral triangle, these three angles are 60 degrees. So if you think about it, we've got an angle, angle, angle situation because the three angles are congruent to these three angles. But are these two triangles congruent? No, they are not, right? I mean, obviously, I drew the second triangle much smaller than the first triangle. So angle, 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 if you just know that the angles are congruent, that is not a way to prove that the triangles are congruent. So let's look at some ways that are possible ways. And this is what we did in class. I made these little explorations, and I showed everybody that you could take, let's say you take these three sides, okay? If I take three sides and I compile them and I use them to construct a triangle like I'm doing right now, right? Is there more than one triangle that can be made out of these three sides? In other words, I could make this triangle face different directions, right? I could rotate it or reflect it or translate it and put it in different places. But these three sides are rigid, and the length of these three sides determines the shape of this triangle. So if I know that the three sides of a triangle are the same as the three sides of another triangle, then I know that those two triangles are congruent. There's no other triangle that can be constructed from these three different lengths. Okay, so side, side, side is one way that we can prove that a triangle is congruent. The next way that we looked at is called side, angle, side. And it's really important to note that the word angle is between the two words side, right? Side and then angle and then side. And so what that implies is that if I want to construct this triangle, I need to make sure that the angle that I'm talking about is between the two sides that I'm talking about. So here's what I mean by that. I'll take these two sides here and I'll rearrange them so that I can line them up with the side of this angle, okay? So that angle kind of just tells me what direction they're going. And then I'll take the same one, or I'll take this other angle, and I'll line it up on the other side of that angle. But notice that I have a side, and then the angle that's between them, and then the other side. Now, I don't have a full triangle yet, but if I use my segment tool, I can draw the third side. It turns out that the length of these two sides is fixed, the first side and the second side, right? Those two sides there are fixed. The angle means that the direction that they're going is also fixed. So it turns out that there's no other triangle that can be made from this situation. Because the length of the two sides is fixed and the angle is fixed, this third side will always go from this point in space to this point in space, and you'll get the same triangle every single time. So if you have two sides and the angle that's in between them, that's another way to prove that triangles are congruent. The third way is called angle side angle. So let me do this one real fast. If you take an angle like this one, and you take a different angle like this one here, and you line them up with a side that's in between them, right? So we have a fixed length here in the center, and then we have a fixed angle on the left and a fixed angle on the right. Well, if I just extend those angles out, right, this line will always go in this direction, and this line will always go in this direction, and they're always going to meet at this point. So this is the only triangle that can be constructed from two angles and a side, as long as that side is between those two angles. So that's our third method of showing that triangles are congruent. Okay, so the next thing that we did was we looked at a few examples and we said, how can we prove that these triangles are congruent? Well, this first set here is pretty simple. I have a side and a side, then I have an angle and an angle, and then I have a side and a side. So I know that these triangles are congruent by using the side angle side postulate, right? Because the angle that's congruent is between the two different sides that are congruent. We looked at another one here, and here we only have this one angle, and this side is congruent to this angle and this side. But then we had to think back to earlier in the year when we learned about vertical angles. And we know that vertical angles are congruent. And so we know that these green angles are also congruent. So this is an example of angle, side, angle. All right, I have the two angles with the side in between them that would prove that these two triangles are congruent. Number 3 here, I actually had to introduce a new property to everybody. So imagine that these 2 points were named A and B. It turns out that I could say in a proof that AB is congruent to BA, because if you notice from triangle 1 to triangle 2, that line segment is part of both triangles. So since it's a shared side, I might need to say that in a proof later. And the reason for that is called the reflexive property. I think of it like AB and BA are the same segment. So when AB looks in the mirror, it sees BA looking back at itself. And that's its own reflection. It's the reflexive property. So anyhow, since we have these sides congruent and these sides congruent, and then you have that shared side, this is an example of side, side, side. 2 more examples to look at. This one, I have side, and then here I have a side and a side, and then we have this vertical angle in between those 2 sides. So this is an example of side, angle, side. And then finally, we have these one set of sides are congruent, but they're also parallel, right? And parallel sides mean we should look for alternate interior angles. So since those sides are parallel, I know that this angle is congruent to this angle because they're alternate interior. And same with these 2 angles here, right? This angle is congruent to this angle. So look at that. I have angle, side, angle. The side is between the 2 angles. And here I have the same angle, side, angle. So that's another example of ASA. So those were some basics. And then the last thing we did in class was we took some notes on some basic proofs, the way that we would actually do proofs. And I introduced this idea of flowchart proofs. I'm going to do these really fast. So you should pause and really consider what I'm doing as I go, because I just want to keep this video as short as possible. So a flowchart proof is a new way of doing things, but we still have to make statements and then give reasons, like a claim and then evidence. The first one, we're going to prove by side, that these 2 triangles are congruent. And this is simple because it's all given, right? It's given right in the diagram that segment AB is congruent to segment ED. It says so right here because they have the same number of tick marks. And so I would just write given under that box. That's where I give my reason. And it's also given that segment BC is congruent to segment DC. So BC is congruent to DC is given. And the last one is also given AC and EC. So segment AC is congruent to segment EC is given. And it turns out that what I've done here is I've shown that the 3 sides of triangle on the left are the same as the 3 sides as the triangle on the right. So I can conclude that triangle ABC, it has to be congruent to triangle EDC because they have 3 sides that are the same. So the reason I give is side, side, side. Now, a very important part of a flowchart proof is I show how the information flows. And in order to use side, 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 I have to have 3 different sides that are congruent. So I draw these 3 arrows, right? And the 3 arrows going into this box here come from the 3 different pieces of evidence that prove that the 3 different sides are congruent. Let's do one here that uses side angle side. Now it says it's given that Z is the midpoint of segment YT. So I'm going to write that in this box. Z is midpoint of YT. Okay, that's given. And what that tells me, so I'll draw an arrow into this box here, that tells me that YZ has to be congruent to TZ. In other words, if Z is in the middle of that segment, then that longer segment, then those 2 shorter segments have to be congruent. Z's in the middle. And my reason for that is that's just the definition, of a midpoint. Okay, that's just by definition. So if Z is the midpoint, then YZ is congruent to TZ. That's a side. It's also given that XZ is congruent to WZ. So that actually means that Z is also the midpoint of that other thing. But let's just say XZ is congruent to WZ is just given to us. So that's another side. And then the angle in the middle are vertical angles. Those 2 angles here are congruent because they're vertical angles. So we can say that angle YZX is congruent to angle, was that TZW? And that's because they're vertical angles. And so that's an angle. So look, I've used side, angle, side. And so I'm ready to make my conclusion, which is that triangle XYZ is congruent to triangle, what is that? T or WTZ, and that's by side, angle, side. And then I have to draw my 3 arrows here because I have to show where the side, the angle, and the side came from. All right, I'm probably running long here, but got to finish this last one. So finally, we have angle, side, angle. And it's given that we have 2 sets of parallel sides. So I'm going to say that M is parallel to N. That's these sides here. That's given. But remember that parallel lines make you look for angles. And so between those 2 angles I have, or sorry, between those 2 parallel lines, I have these 2 angles that are congruent, RQS and PSQ. So I'll say that angle RQS is congruent to angle PSQ because those are alternate interior angles. And my arrow says it came from that parallelism. Then I have these 2 sides that are parallel. So I know that PQ is parallel to RS. That's also given. Okay. And then that's also going to lead to some angles. In this case, that's going to lead to this angle, PQS, and this angle here, RSQ. So angle PQS is congruent to angle RSQ. So I have a couple angles. Those are also alternate interior angles from a different set of parallel lines. So I have angles and angles. And then we have this side in the middle, QS, which is congruent to itself because it's part of both of the triangles. And so that's where I use that thing called the reflexive property to say that it's congruent to itself. And so I've proved then that triangle PQS is congruent to triangle RSQ. Darn it. I'm going really fast now, trying to finish this video off. Triangle RSQ because they meet the angle side angle criteria. Because I have 2 sets of alternate interior angles with the side in the middle. And so then I draw these arrows and I'm done. Come to class on Thursday with these copied down and ready to try your own proofs. See you then.